So just FYI, I did go ahead and start recording the event, so we'll be able to post it after the webinar. So those that couldn't make it will have the chance to view the webinar today. So thank you for joining us. My name is Ben Edelman. I'm a researcher with the Texas A&M Transportation Institute on the Center for Advancing Research in Transportation Emissions, Energy, and Health. Today, our webinar will be talking about educating the future workforce on transportation emissions, energy, and health. A quick overview of our agenda today. We're going to have Joe Zietsman from Texas A&M Transportation Institute providing an overview of CARTEEH's educational mission and programs. We will have Natasha Wilkerson from Texas A&M University talk about health transportation education in school STEM programs. Then Dr. Mary Fox from Johns Hopkins University will talk about how she's using CARTEEH research as a teaching tool in environmental and occupational health. And then finally, Dr. Mike Rodgers from Georgia Tech will talk about how he has worked with his colleagues to develop an interdisciplinary transportation, air quality, and health course at Georgia Tech. And then we will wrap up the webinar with some facilitated discussion, Q&A, and go from there. So with that, I will turn it over to Joe Zietsman. He will kick us off. Joe.
Thanks, Ben. I appreciate the opportunity. And what I'm really going to do is set the stage for the three presenters following me, because my colleagues here at CARTEEH have been doing some excellent work on the education side. And all I'm going to do is basically set the scene and set the stage for the three presenters following me in terms of what we've been doing on the education front. So Ben, next slide, please. So what I will be focusing on is firstly just say a few words about the CARTEEH Center, and then I'm going to be talking about where does education fit into CARTEEH in terms of our current mission, and then finally, where are we heading with this education topic, which is very important. That's the part that really excites me, is where are we going? And I think we're just basically scratching the surface when we talk about education and where we can go from here. So a few words on CARTEEH. As Ben said in the introduction, CARTEEH stands for the Center for Advancing Research in Transportation, Emissions, Energy, and Health. We are basically focused on the intersection of health and transportation, and specifically in the areas of emissions and energy as they link up and relate to health. And it is a broad topic, as we've definitely discovered in our work at CARTEEH. It's a multidisciplinary issue. And we are very fortunate to have a consortium of university members participating and being members of the CARTEEH team. And as you can see on this map, Johns Hopkins University, Georgia Tech, University of Texas, El Paso, and UC Riverside are all key team members, and they all bring unique capabilities to the center. And I will talk a little bit more about that in a minute. So just to recap again, CARTEEH is a Tier 1 university transportation center funded by the U.S. Department of Transportation, and we're very grateful for the funding and the kind of work that we are able to do here at CARTEEH. Next slide, Ben. So in terms of the focus areas, it's really three areas that we're focusing on at CARTEEH: research, education, and technology transfer. And these are not areas that we came up with at CARTEEH by ourselves. These were actually directions from the US DOT directly, and they basically said, these are your three focus areas. All we did was to organize it in this three-legged stool, because we found it very relevant to look at it as three legs of a stool, because what it really does is it shows us that not one of them is more important than the others, because if they're out of balance, one leg is being handled too strongly, or some other leg is not handled at all, you get out of balance, and then we lose the impact. And that's really what we're trying to do at CARTEEH, is have impact. And in terms of research, that's the first leg of the stool. We feel pretty good about the impact that we're having on the research front. So normally these university transportation centers are very strong on research. So we feel pretty good about where we've really stretched the whole mission in terms of CARTEEH, in terms of research. We pushed the envelope, and we've really came up with new state-of-the-practice and state-of-the-art concepts on the research side. When it comes to technology transfer, that's a little bit more difficult, because tech transfer is really taking your what you find and discover on the research side and put that into practice. So it's not as simple as one might think, but it is a huge emphasis area of the US DOT. So we've been taking it very seriously the past few years. And I can give you one example of where we very much were able to do technology transfer in a big way, and we're putting our research findings and some of the technologies that we've developed under research into practice, and that is in the area of electric vehicle and vehicle electrification. We were able to develop a software package that basically does charging demand estimation. And obviously, I think everybody knows that vehicle electrification is a huge topic currently, so that software is being very well received. We're able to license it. And two of my colleagues here at TTI were even able to spin off a startup company because of that. So when that company generated some venture capital from Silicon Valley, so they're obviously off to the races, and there's a lot of implementation and putting into practice happening through that technology. So we're very fortunate and very happy that's what's happening on the tech transfer side. On the education side, it's obviously the transfer of knowledge and skills to the next generation, and even broader than that. So that's what we will be talking about today. And like I was saying in the beginning, I think we're only scratching the surface, and we're very excited about where we are and where we're heading. And I think the future is very bright, and I'm really excited about our future vision when it comes to education. And that will be the focus of the three presentations following me. And one more thing I want to say about education. It's not only about students, it's much broader vision than just students. So we'll talk about that in a minute. Next slide, Ben. So in terms of the focus areas of CARTEEH and our sort of scope, I like to show it with this basically urban setting, and we talk about the tailpipe to lung spectrum. So in an urban setting like this, and if you look at the first square box, we have traffic, and if you have traffic, you have emissions, and if you have emissions, it disperses into the atmosphere. People are exposed to those concentrations over time and space, and those result into health impacts. So that is what we call the full chain from the tailpipe to the lungs. And that is why it is such a multidisciplinary problem, and why we have a consortium of universities working with us. It's not just traffic engineers, it's actually a multidisciplinary team working together. And on the left, you see that triangle that talks about technologies and disruptors. And that is very important because transportation is changing rapidly, and there's so many disruptors, and we need to keep those in mind as we work through these different topics in the center. And then we also need to keep in mind that we also need to look at long-term impacts in terms of climate change, and a lot of the emissions we're talking about are greenhouse gases, so we need to keep those in mind as well. Next slide, Ben. So in terms of multidisciplinary, we show it there in those three bubbles: transportation, emissions and energy, and health. And transportation, obviously, we look at that from the perspective of the vehicles, the traffic, the network, and we see that more as an input to this three levels and three tiers. The emissions and the energy is like an output. And then the health is like the outcome, what really comes out. And that is what we also focused in on CARTEEH. What are the health implications? And not only disease, but we also care about social health, physical health, and mental health. So it goes much broader than just disease. And to the right, you see a couple of groundbreaking projects that we've done that really tease up in terms of the multidisciplinary approach, and also talks about where we're going to head in terms of education. One of them is the 14 pathways between health and transportation. We looked very carefully, how does health and transportation link? And we came up with 14 links or pathways. So that recently got published in a high impact journal. So we're very happy with that work. And then we also, maybe a year and a half ago, we looked at what would be really impactful in terms of CARTEEH's future direction. And we came to the conclusion that infrastructure is going to be very, very important. So that was about a year and a half. We came up with a concept of smart infrastructure to improve public health. And the idea there was to come up with methods and concepts how infrastructure and infrastructure planning and implementation can be done in a better way so that we have better health outcomes. So that project is going forward, and we've got multiple pilot projects involved under the SMART concept. Next slide, Ben. So now we're focusing on health, on education specifically, and with the multidisciplinary team in CARTEEH, we quickly realized that everybody on the team, and we look at the consortium of universities, they all bring unique skills and capabilities to the table, and they're all a little bit different. Since we have health expertise, we've got medical doctors, we've got public health experts, transportation professionals, mechanical engineers, so a whole spectrum of people working together on the CARTEEH Center. So we came to the realization maybe an impactful thing to do is to put together a curriculum and have the CARTEEH membership, our consortium partners, participate and develop lectures that we can put together in a curriculum. And that's what we started working on. That was a big undertaking, and all the partner universities participated and delivered lectures. And that's all part of this tailpipe to lungs chain, or this whole spectrum. So they all delivered pieces of the puzzle, and if we put it together, it really paints a full picture in terms of this whole tailpipe to lungs notion. So we're very happy with the curriculum. We developed a syllabus, lecture slides, a total of 48, including speaker notes, so it's actually easily usable. We even developed a textbook, and that textbook is called Transportation Traffic-Related Air Pollution, and so we used this lecture material to develop a textbook. So the significance of this curriculum is that it's scientifically rigorous. So it was developed for university students. So it's at that level, but it's easily adaptable and adoptable into different, for different audiences, as you will see in a minute with some of the other presentations. It's modular. So for example, we can mix and match from the curriculum. For example, Dr. Fox can be teaching health professionals, and she can be using transportation lectures to teach them about that. And she will be doing that at Johns Hopkins University. Similarly, Dr. Rodgers can be teaching a class to transportation students, and he can be using some of the health lectures in that class. So that is the vision, and that's how it's coming together. So like the next bullet says, it's adaptable to other audiences, and that's for sure. So we can talk to health professionals and others. And Natasha Wilkerson will talk about how that curriculum can even be adapted to talk to elementary school kids. So the foundation is still the curriculum, but we can adapt those lectures and learnings to any level. And we'll show that in a minute. So at the bottom, you'll see the link to the curriculum, and that's downloadable, and one can utilize those lectures. And to the right is just basically the kind of how we set it up. And that's, again, consistent with the tailpipe to lungs spectrum I've showed before. Basic air quality, that's the first green box. Monitoring and modeling, exposure assessment, health impacts, burden of disease assessment, and finally, policies and technologies. So the lectures are organized according to those key topic areas. Next slide, Ben. Finally, as I say, I'm so excited about where we're heading with education in CARTEEH. I think we're just scratching the surface, and it's been a true blessing to work with our colleagues here at Texas A&M University, for example, the College of Education, plus our partner universities. So we've really been focusing very, very hard on education the past couple of years. So the first bullet there says we still link to research and technology transfer activities. So obviously, education is one of the three legs of the stool. So we're very much focused on the other two legs as well, and they do intersect and they do talk to each other. The curriculum will continue to be the basis. So with the scientific rigor, and we will continue to enhance and improve the lectures. At some point, we actually want to go ahead and video record them so that we have them available at that level. We will continue to expand that, include lectures to that. So that will be the basis as we move forward. And it's not just traditional transportation fields, as I've said before, and the next bullet talks about students of all ages, from pre-K till postdocs. There's just no limit in terms of who can be taught through the curriculum and other methods, utilizing the curriculum as the backbone. Next one talks about supporting continuing education. I finished my grad studies more than 20 years ago, but there's no reason why I cannot, for example, continue to be educated in some of these fields. So continuing education, and then decision makers and general public. To me, that's almost the most significant bullet on the slide, because really, if we can get to decision makers and the general public, that will enhance the decision-making significantly and also the political will to do certain things. So in terms of rolling out the education program that we will be showing you today, that's where we will want to go next and want to continue to expand our reach in terms of where we want to go with these topics. So that will be the next one, and then we're very, very excited about how we can reach the public and the decision makers. And finally, obviously, the focus on EJ, disadvantaged, underserved, and underrepresented communities. It's clear to all of us, and it's been shown multiple times in the CARTEEH Center, that those kind of communities and groups are adversely impacted, especially when it comes to air pollution and the associated health impacts. So I think it's just the right move to also definitely focus on those communities when it comes to education, and bring them up to speed, and also help them in the decision-making process so that better decisions can be made. Thank you. That's all I had as an intro.
Thank you, Joe. I appreciate that. So we will swiftly transition to Natasha Wilkerson. She'll talk about some of the work that she's been doing in Bryan College Station area, supporting health transportation education in schools. Natasha?
Yep. Great. So I think the next slide will kick off my portion. So I'm excited to be here. I'm representing the College of Education at Texas A&M. I'm one of the education researchers on this project. And our focus is translating the materials that Joe mentioned and the overall framework to the K through 12 audience. So it's a lot of content, and we're trying to figure out what are the key areas we want kids to know about, as well as teachers and their parents. So next slide, please. So looking at the big picture, there's a lot of different areas and different approaches. And so our goal is taking the sustainable transportation framework, the curriculum that's already been developed for the university level, and making it something that can connect with the students. We are looking at the full range, as Joe mentioned, from pre-K all the way to 12th grade. And is also a general goal is to increase their interest in STEM careers, as well as targeting those communities that are underserved, underrepresented. Next slide, please. So here's the big picture. There's 5 different components of the education workforce development vision. On the left, you can see the curriculum, and what we mean is, again, those university modules, but adapting them in K through 12. And we have 2 different directions. One is through a classroom version, something that a teacher would implement in the classroom, as well as an outreach kit. So often schools will host a big event like a STEM family night where there's hundreds of people attending. How can we do a quick activity to really engage the general public? Tied with the curriculum is the training. So we can't expect to just develop curriculum and that teachers can just put it on. We need to make sure that they're using research-based practices in teaching the content effectively. So we're using our knowledge as educators and educational researchers to help prepare those teachers to implement the curriculum in K through 12. And with that work, we hope to add to the research body around science education, some of these socio-scientific issues. What we're realizing as we're creating this curriculum, there's a lot of misconceptions that students and teachers have on these issues, and we're trying to identify what those misconceptions are and how do we change them? How do we change behaviors and attitudes around these critical public health issues? And then that runs into programming. So the curriculum that we're developing, and I'll talk to here in a minute, we want to actually try it and pilot it and bring it to our teachers and our students through various different events. And we're also looking to provide the kits and funding to schools that they can then have access to all these materials. So now I want to talk about some of the efforts that we're doing this year. So next slide, Ben. So the focus of this school year, I mentioned two areas. So there's the STEM outreach kit, where we have an event with hundreds of people. What's a quick, catchy activity, in 10 minutes to really get across some key messages? And then how can we take that activity and translate it into a classroom setting where teachers will have multiple sessions with the kids and to bring in some key areas, in transportation, health, and so on. Again, providing training and then implementing that programming. So if I can go to the next slide, I want to share with the first piece on STEM outreach. So in these events, the challenge, and I've put on many of these STEM nights, there's a lot going on. We have to grab their attention. So it's finding kind of that wow, catchy activity. So what you see pictured here is the pair of real pig lungs, and we're showing the impacts of air pollution. And so this is a picture from one of our events where the mom and the daughter are pumping air into the lungs and looking at these differences. And that brings in, gets an emotional response from the public. And then what's going on? Why is this happening? And that we can increase awareness around air pollution and the impacts on health, tie it into CARTEEH, and then get some interest in STEM. So with the next slide, Ben, the way we created this kit is there, and you can click here again. First, we're looking at what is air pollution, how is it measured? You'll see pictured here is Jeremy, one of the research scientists at Texas A&M, and he brought out his equipment and he's sharing with students live data that he was collecting in Dallas. And the students had a chance to use those air quality monitors, and we had a simulated air pollution demonstration where they got to collect some data and understand how that works. Click again, and you'll see what is then that air pollution's impact on health. And so those are those pig lungs that I mentioned, and we got quite a reaction to these, and that was probably kind of the key thing that brought people to our station, and they were just fascinated to see these impacts. But we didn't want to end with, okay, there's all these issues. So if you click again, we wanted to then say, well, here's what we're doing about it. And that connects very directly into what CARTEEH's research is on transportation emissions and how can we reduce air pollution. And we asked the students, what can you do in our community here in Bryan College Station to reduce air pollution? And so we created this big mural and the students brainstormed different ideas. And with the next slide, and this was an event in October, we were able to collect some data. So this was a pilot of that STEM outreach event. We had over 200 participants, and this was elementary students and their parents that came through the booth. We saw some from the pre-post surveys that we did. They reported increased knowledge on air pollution, awareness of the work of CARTEEH, especially in connecting with that research scientist that was present, and then just feeling more empowered on that they could do something about reducing air pollution. So that was our, quick outreach event, and there are challenges there. You only have 10 to 15 minutes in this kind of chaotic setting. And so what we're excited now is to take that event and turn it into lessons for teachers. So our next slide here is talking about the development of a classroom kit. We are focused here 5th to 8th grade. The key is we've got to align with the science standards if teachers are going to be able to put it seamlessly into their classrooms. So our goal is to have science teachers take lessons. They would span 2 to 3 45-minute lessons, and we would train them based on how people learn, what is developmentally appropriate for those grades, to deploy that curriculum aligned to their standards. Our goal is to make it scalable, and so it won't be overly expensive, especially if we're targeting those underserved students, and we're providing funding through the center to have access to that curriculum. We just piloted this content last Saturday at a workshop here at Texas A&M with a group of 6th grade girls, and they walked around Texas A&M collecting data on different particulate matter levels and talking about emissions and looking at the impact of transportation and then taking it to that aspect of health. The exciting part now is getting this in the hands of teachers. And so we put out an interest form. We took it out to our networks and said, we have this curriculum, we have these kits. Who is interested in implementing this in the spring in their classrooms? I just checked it this morning, and we have over 500 teachers across the country that are interested in getting access to these kits. And so our plan is, starting right back in the spring, is to deploy those out. We're going to allow them to download the curriculum right away, and then we're going to have a process to get out some of these kits into the hands of students and teachers. So that's what we're working on here at A&M, and we're really excited to continue this work. And so that's what I have here, and I'm going to now pass it off to Dr. Mary Fox.
Thank you, Natasha. Appreciate it. And I must say we had a lot of great feedback about the events that you've had. They really were special. So thank you so much. So yes, we'll hand it over to Dr. Fox, who will talk about her work incorporating CARTEEH research as a teaching tool in environmental and occupational health. Mary?
Great. Well, thanks so much. And thanks, Natasha, for getting us going on this. To talk about, you know, the partnership. You know, Joe mentioned how, you know, CARTEEH is a multi-university consortium. CARTEEH contributes to Hopkins. Hopkins contributes to CARTEEH. So I'm going to show you a little bit about how, but the more important part is kind of why it matters and so what. So in this transition, we're taking a jump from K-12 education into graduate school. And so let me start. Ben, go ahead. You can do the next slide by giving you a little bit of context. So I teach a method called human health risk assessment. I'm sure many of you are familiar. It's a core methodology in environmental health policymaking. And it's you know, it's a method, it's a process, it's multidisciplinary, right? So it really gets at the core of what CARTEEH and the UTCs are about. But it's, you know, its target is policymaking, decision making. And the goal is to make the best use of all of the available information, integrate it in a way that can inform decisions. And this tool is used, you know, in the very broadest sense of environmental health. So certainly for air, which is one of the main concerns of CARTEEH, but in all sorts of other ways, in food safety and products, in water, in worker health, and so on. Let me continue to set the stage a little bit. Ben, can go ahead. So I'm part of a certificate program. Risk Sciences and Public Policy is what we call it. It's a 3-departmental collaboration here within the Bloomberg School of Public Health. And just to give you a sense of what we do and the students that we reach, you know, it's primarily for master's students, but we have a good representation of doctoral level students as well, and a little bit of continuing education. In fact, the program, the certificate itself, was originally created as a continuing education program because we felt that, you know, a lot of policy makers and people interested in policy development weren't well versed in the integrated science training that's needed for complex decision making. And just to say what the risk sciences are, at least from our perspective. So biostatistics, epidemiology, exposure science, and toxicology are the main risk sciences that we teach and integrate in our programs. And you can see that a little bit in terms of the number of students and the departments of the students that we teach during the CARTEEH years, which is since 2017. So primarily, you know, most of the students have come from our Department of Environmental Health and Engineering. and also good numbers in epidemiology, health policy and management, and then from other departments throughout our school, in fact, international health and the other lab science departments as well. Go ahead, Ben. And maybe, and sort of most importantly, right, so we want to get at that impact. So how does our educational program really make a difference? Well, I can tell you, and I'm proud to say that our students go into the highest levels of government, into consulting firms, advocacy groups, to the national academies, technology and pharmaceutical companies. So we really feel like we are building a foundation or a launching pad even for people who can have a lot of impact and influence. Next slide, Ben. Thanks a lot. So, so that gave you a little bit of context in general of the program that I'm working in. My particular area in human health risk assessment is called cumulative risk assessment. It's one of the relatively recent developments in this area, although it's been around for 20-some years. It's still not very well implemented across many sectors, but it's about getting real. You know, our exposures are not just to multiple chemicals, but other non-chemical stressors. And, you know, as we've learned during the pandemic, you know, environmental exposures such as air pollutants have a big influence on COVID risk. And so that's the kind of thing that cumulative risk assessment is really all about. And next slide, please. And I hope you're following along, and you know, in terms of the concepts, it's not a big jump to say that transportation and health, which is the core work of CARTEEH, is a cumulative risk issue. It was, you know, it's the most important reason, I think, that I was so excited to be part of the CARTEEH work. Can you go ahead, Ben? Yeah, so, and this is just to say this little spot that we've brought onto the slide now, just to hopefully bring this home a little bit, you know, what the cumulative risk concept is, and particularly in the context of transportation and health, is that all of us are, you know, are at the center of this intersection of multiple microenvironments, they're sometimes called. I mean, it's all of our domains of life, right? We have, you know, our personal sphere. We're all within the ambient environment. We have community influences. We have workplace influences. And all of us are impacted in sort of health promoting and health damaging ways in all of these environments. And that is the essence of cumulative risk. Go ahead, Ben. And so now kind of honing in on the intersections that Joe mentioned within the, you know, the three legs of the stool. So the research to education part, which I'm going to focus on now, this health risk characterization of refueling for drivers and workers was one of the research projects that Hopkins undertook as part of CARTEEH. And this slide just captures really quickly how we operationalized our cumulative risk approach to this issue. We had we developed a personal sampler and also a survey instrument for our participants so we could get a sense of their exposures primarily to the BTEX chemicals, so benzene, toluene, ethylbenzene, and xylene. So BTEX chemicals and their personal behaviors and refueling. We looked at secondary data, the National Air Toxics Assessment to get a sense of the ambient exposures. We also inquired about potential work exposures through our survey instrument. And to make it, you know, truly cumulative and to bring in the community health piece, we built in a lot of other secondary data sets so we could really ground the information that we learned from our participants well into their own community settings. So this is the research project that we have then been able to incorporate into in various ways into our educational work. Go ahead. So over the 5 years that we've been working with CARTEEH, we have been able to build this research content into several courses. One of my main courses as part of our Risk Sciences certificate program is this first one here, Methods in Quantitative Risk Assessment. And this is, it's a policy course, but it's the, nitty-gritty methods of the risk assessment process for environmental health policy. And, the teaching students the conceptual and then the practical application of cumulative risk within our research project has been a feature of my methods course for several years. I also teach in environmental and occupational epidemiology. And so again, we're in this context, we're teaching the epidemiology students about, again, the practical applications of the risk assessment methods that rely very heavily on their research. And of course, we can't forget the very key exposure sciences. So it's been a pleasure that I can contribute to the exposure sciences for health risk assessment course. Again, using the research project that we conducted for CARTEEH. And in this case, many of these students come in with a good knowledge of the air pollution exposure assessment methodologies, but within the context of our cumulative risk research for CARTEEH, we can talk about how we understand and how we measure some of the non-chemical stressors and how they can incorporate those then into their research. So go ahead, Ben. And so, I mean, these are the core concepts, competencies, and skills that you would want to instill in any research student, I think. But, we really can cover the full gamut from study design, equipment design, instrument design, data analysis, both for primary data and secondary data, when you and how you combine those in an integrated project and assessment, and then how we interpret all of this, integrating evidence across the multiple streams of data that we have, characterizing the health risks, and then that final and kind of key important step, figuring out what the policy implications and what the decision-making implications are. Go ahead. So just to wrap this up, for sure, this is a multidisciplinary effort. We're looking at health science, exposure science, and we're figuring out how we translate that to policy. But I like to call this also transdisciplinary. And, I looked this up to see, is my definition the same as what you might find in other sources? And in fact, it isn't actually. You look it up and it's more like multidisciplinary, but I don't think that's not going far enough. It's great to get multiple disciplines in the room, but if they aren't able to communicate with each other, then you're not getting very far. So I think we're really getting to this transdisciplinary kind of common framework and language idea. So we're giving our students ways that they can connect with the other disciplines and make sense of those connections. And ultimately, it's all about influence and impact. The great thing about the risk assessment framework is that it is completely built into a lot of our environmental health policymaking. And if we have our students well trained, they're going to the right places to have that influence and impact on the way we do things going forward. So thanks again.
Thank you, Mary. Really appreciate that. So we will quickly transition to our final speaker, Mike Rodgers, and he'll talk about, again, his work. Advance the slide one more. His work at Georgia Tech, developing a transportation, air quality, and health course. So share his experience with that and provide some interesting details. Mike?
All right, thank you very much, Ben. Well, we're going to talk a little bit about our work in trying to operationalize these concepts of at least at the university level. Okay, the next slide, please. Of course, CARTEEH has this basic mission associated with energy emissions and health, and thus it's kind of inherently a multidisciplinary, interdisciplinary type of activity. It's of interest to transportation and emissions professionals relating to vehicle activity and vehicle emission rates and sort of estimation of total emissions. And air quality professionals are associated with looking at how this transforms and disperses in the atmosphere, and public health people involved in exposure assessment and health effects assessment. So this is essentially what Joe mentioned earlier about this sort of complete package all the way from the vehicle all the way to the lungs. And we looked around the Georgia Tech and Emory University campuses for courses that would be involved in this area, and we found they generally fit into two categories. The technical courses tended to lack one or more elements. That is, we teach a course, graduate course in transportation, energy, and air quality, but we have not included health effects in that, or similarly, or other types of activities. And courses that did cover it all tended to be more survey or overview type courses without a lot of specific technical content. So the intent of the design of the course was to look at something that could offer sufficient technical content to be a meaningful contribution to professional education, while also covering the broad overview of what we're trying to do from tailpipe to lungs. The next slide, please. Now, CARTEEH had two major educational initiatives in that regard, and Joe has already talked about the first, which was the development of model course materials, including these modular courses, the textbook development, and some supplemental lecture materials created. When that began, a parallel activity was to try to develop a pilot course. And so we began in February of 2018 to look at how would it take to design a graduate or upper level undergraduate course in transportation and health to handle it effectively. So we decided to focus on senior level undergraduates because that was an area where we'd had sufficient technical background that they knew their own field to some extent, and that we could broaden their horizons on whatever other material they had not previously seen. So to do that, we had to ensure that they had fairly limited prerequisites, which would allow a broad range of majors to enroll in the class. And so we settled on just basic calculus, statistics, and systems theory, which would allow us the broadest range that we could have for a particular pool of students. Now, we wanted to include it as to make it attractive to both science and engineering students. We needed to incorporate enough technical material that it would count as a technical elective for both engineering and science degrees at Georgia Tech. Fairly early on, we realized it was going to be very difficult to staff the course with an individual instructor who could cover everything that was needed. And so we very early on decided this would be team taught in some meaningful way, both to cover a range of expertise, but also to have people who were familiar with the different backgrounds of individuals and what a particular major at that level might have been exposed to. If I could have the next slide, please. So we essentially originally proposed the course in spring of 2018 to be taught as a special topic during academic year 2019. And so in the spring semester of 2019, we offered our first version of the course, We originally had 26 students involved, and these came from 5 different majors, including civil and environmental engineering, industrial and systems engineering, biomedical engineering, mechanical engineering, and management. We offered it again in a slightly modified fashion, learning a few mistakes along the way. In spring semester of 2020 to 31 students in 7 majors, which also included earth and atmospheric sciences and public policy, as well as chemical and biochemical engineering. Based on the results of those 2, the favorable reviews from the students and the like, the course was approved by the Georgia Tech Institute Curriculum Committee as a permanent course to be added to Georgia Tech curriculum in February of 2021. And so we are currently teaching that as we speak. In fact, the final examination presentations are this evening at 6 o'clock if you are in the Atlanta area. And it will be offered annually to these courses moving on. This semester, we're having 27 students. And so that seems to be about what the demand sits right now. Got the next slide, please. Now, to pull this off, we needed a fair amount of resources from the instructional side. So I was the primary instructor of record, but we also brought in 2 additional, a research engineer, now an assistant professor at the University of New Mexico, Haobing Liu, and he was replaced by another senior 5th-year PhD student who's an expert in dispersion modeling to teach the course. And we also brought in a PhD student from this, who was also a CDC public health officer to help on the epidemiology and public health exposure side. To add to particular activities, we brought in a variety of guest lecturers, including Liz York from the Centers for Disease Control and Prevention, Andrew Dannenberg from the University of Washington School of Public Health, Sandra Willis, now Sandra Willis Rodgers, a benefit of CARTEEH, who's a health psychologist at Stanford University at the time, looking at psychological effects associated with chronic lung disease and chronic activities, as well as Michael Garber from the Rollins School of Public Health at Emory University. And we asked particular individuals around campus to contribute materials and expertise associated with their activities. And you can see them mentioned here, including Mary, who graciously offered some material that she was also developing that would eventually end up into the modular course materials that we now have available in CARTEEH. So if I get the next slide, please. Now, there's a lot of material in this slide, but essentially the course follows that same sort of process that Joe talked about earlier. We began with 7 lectures on air pollution and mobile source emissions, follow that up with methods of exposure assessment, and then the effects and impacts of these emissions on public health, and then follow it with policies and technologies to mitigate these emissions. But a lot of the work is associated with 2 half-semester-long projects, which form the key for the experiential learning process for these students. If I could have the next slide, please. Project 1, which spends roughly midterm, is essentially a project that's designed to use current regulatory tools to estimate emissions from a major transportation facility. One of our collaborators, Dr. Anshuman Nguyen, collected second-by-second data from I-475 in Macon, Georgia, that allowed us to have 6 days of travel with identified classified vehicle counts, from which we could use a couple of regulatory models. The MOVES matrix model, which is a enhanced version of the MOVES model, which has been developed here at Georgia Tech for light-duty vehicle emissions, and the Georgia Tech Fuel and Emissions Calculator, which we developed in collaboration with Oak Ridge National Laboratories for the Federal Transit Administration to look at heavy-duty emissions. And so those tools are used by the students to estimate second-by-second emissions from this interstate highway. They use that same information in the beginning of the second course, the second project, which is geared toward estimating what the health impacts are. By incorporating those emissions both from the freeway and from arterial roads, flow those into a dispersion model, the EPA air mod model, and look at what potential exposures are for these pollutants at particular receptor sites. If we could have the next slide, please. To do this receptor, we picked a section near downtown Macon, Georgia, which is in central Georgia. And from that, we isolated particular locations. The next slide, please. A series of schools that are located in this vicinity. Next slide. A series of hospitals that are located in this facility. Next slide. A suite of nursing homes and assisted living communities. And lastly, a set of recreational area at the Okmulgee National Monument and the Macon Riverwalk. And so we asked them assume with certain assumptions about human trajectories through these environments. We assess those and use a simple health effects model to allow them to estimate the human health effects. The next slide, please. Now, of course, that's a particular process aiming. It's going to be something different for every individual, whether they're a transportation person, they're going to be learning about the health. If they're a health person, they're going to be learning how to use the tools of the transportation. And so those are the types of activities that we're looking at. And so far, the feedback has been pretty good. The undergraduate students in all these different majors have proven that they're both able to learn and apply these models to in this end-to-end move. As we said, this includes an emissions model, two different emission models, MOVES matrix, which is based on the EPA MOVES model, a heavy-duty emissions calculator, the EPA air mod for dispersion, a simple exposure model, as well as a health impact model, which we incorporate from that. So it's been highly rated by the students, albeit with a very intensive amount of resources that are necessary to support that. The intent of that, of course, is that to use the ultimately use the CARTEEH materials to lighten the load, if you wish, of having to provide these, since we were actually developing these in parallel with the CARTEEH materials. We sort of had to do a little bit of duplication of effort. The next slide, please. Now, sort of the last slide here is kind of showing up what we've offered. As we've said, it's been approved as a permanent addition to the engineering curriculum of the School of Civil and Environmental Engineering. It's also available as a technical and approved technical elective for all Georgia Tech STEM undergraduate degrees. And it's also been incorporated into our new proposed public health minor at Georgia Tech, housed in the School of Industrial Systems Engineering, and is going to be one of the health and environment curriculum. Now, we're currently expanding this to a broad range. Georgia Tech has a longstanding relationship with Emory University. In fact, the Georgia Tech biomedical engineering is actually joint with Emory University. So that relationship has been going on for a long time. And we plan on piloting in the fall of 2022 a graduate version of the course to be taught both at Georgia Tech and at the Rollins School to look at this on an even more in-depth level. With that, we'll stop and take any questions you have on any of these curricula. Ben?
Thank you so much, Mike. I appreciate it. And thank everyone for these exceptional presentations today. So I don't see any questions in our chat box. And given the number of folks that we have joined today, I think it'd be perfectly comfortable if anybody wanted to unmute themselves and ask a question if they had one. So we'll go ahead and wait and see if anybody either has a question in the chat or wants to go ahead and speak up in the last couple minutes that we have for questions. When we have such a comprehensive such comprehensive presentations from folks, it just leaves no room for questions.
Ben, if I could add something
please.
to it,
yeah,
in terms of sort of integrating this together, sort of the intent of the pilot study was to find out how you might do things. So get some of that feedback that would ultimately work into the modules that we provide. And so I think the materials that are being provided by CARTEEH right now represent enough of a framework that most universities could consider offering a course in this area with the supplemental materials that are available from CARTEEH. So we feel very much that some of this background material, which was had to be sort of generated out of whole cloth for some of this material, is now available more broadly. And I think it will become, as was described by Natasha, will become even more broadly available as time goes on. So I think there's a real opportunity to incorporate this in training programs for a wide range of different activities, both within government and industry, as well as education institutions.
Absolutely. Yeah. And we did get a question for you, Dr. Rodgers, asking if you're planning to make your course materials available for others to use.
We do. We have a policy to do that, and that will be material. Of course, each time we've offered the course has been slightly different. This is the first time we've tried to incorporate the CARTEEH materials into the course, and it represents about 30% of the material we're using as some modifications of the CARTEEH material. But we have recorded a series of special purpose lectures, specifically those that are designed to use the tools that we're talking about. That is the EPA, the MOVES matrix, the EPA AirMod module, and some background information, sort of user guides that would allow other people to implement this within a course for themselves. And so that's something that will be available at the end of this semester when we roll into our archival for the course materials.
Wonderful. Thank you. I appreciate that. It doesn't look like we have any other questions. So I think in the interest of time, we're just 1 minute shy of 1 p.m. Central. So I think we did a really good job sticking within the allotted time. So just want to thank our speakers, Joe, Natasha, Mary, and Mike. Excellent job. We covered a lot of ground. This wasn't a typical webinar where we kind of focused very narrowly on one project. We really covered a lot of ground, and so I just wanted to extend an additional note of gratitude to our presenters, because it was challenging to put this presentation together to be concise but comprehensive, and as usual, our presenters nailed it. So thank you very much. We appreciate that. This presentation and both the video as well as the slides will be posted on the CARTEEH website. So if folks want to download those or send them to colleagues, they will be able to do so. And otherwise, we'll go ahead and let everybody enjoy the rest of their afternoon. Thanks so much for joining, and have a great day.
Yeah.
Thank you.
Thanks, Ben. Thanks, guys.